Okay, last one, quota sampling. Your quota sampling is very similar to your stratified sampling. So I don't know if you want to like kind of link these two and be like, hey, they might be kind of similar. The reason why it's not random, whereas stratified random sampling is, it's how you decide to then gather your points of data. So with quota sampling, you divide your population into subgroups and use non-random methods to gather data from each stratum. So let's say, like with your stratified random sampling, we've divided the whole school into grades. With each grade level, you then need to pull 10 points of data. The non-randomness is if you decide to pull 10 points of data from the same class period, right? That is convenient because they're all in the same class period. So you just go in and say, hey, you 10 kids that are all in the same class or in the same grade, I'm going to have you fill out this form. But maybe this is an accelerated math class that you just went into. So it's a very small group of people, of subgroups of that grade level that you're looking at. So it could be not an accurate representation of that entire subgroup of that grade level. You could also then do truly random sampling within that grade level, but then only be discarding ones that don't fit the category that you're looking at, right? So you could say, I need to gather data for the entire school, but I've got a ton of like 9th, 10th, and 11th graders, and I need to gather more for the 12th graders. And so what you do is you do truly random sampling where you gather from the whole school, but then you dismiss everybody who just participated and only focus on the 12th graders. So dismissing points of data because it doesn't fit into the certain quota that you've set for that number, for that subgroup, is what makes it not random. So dismissing data that doesn't fit into the category, that doesn't fulfill the quota that you were looking for. Maybe you've already gotten enough 9th graders and then you start to dismiss the 9th graders who are participating because you just really want to focus on the 12th graders. So that's quota because it's not random. It's good because B/C, because it represents a potentially underrepresented population. Maybe the 6th graders aren't really heard all that much because they're shy and they're timid and they're really sweet, but they don't talk at all. And so maybe the 12th graders, who are like the eldest, they're on top of the social hierarchy. Maybe they are like, maybe 12th graders are just, they're more outgoing and talkative. And so they're heard more. Their issues, their concerns are heard. 6th graders never speak out on their concerns or their issues, right? So this could be good where you're like, I don't have any 6th graders represented. None of them volunteered to do my data. I need to really focus on getting 6th graders to fulfill this quota. It could be good. It's just not random. It's bad because it's not random and could potentially not be accurate. All right. Back page. Let's talk for a second about how we decide the numbers that we pull. This is one way that you can decide the numbers that we pull. We're just going to practice it really quickly. It's your stratified number sampling. So if we have a wildlife park that has 30% of the big cats that are lions and then 70% of them are tigers, we're going to select 30 cats. So how do you select those 30 cats? Oh, well, yeah, we're not even talking about the number that we're pulling. We're just talking about how do you select between those categories. So the idea is that you have a population that is 30% of one and 70% of the other, which means that when you go to a sample, it should also be 30% of one and 70% of the other. So what you need to do is if you're selecting 30 big cats, 30% of the big cats need to be lions, and 70% need to be tigers. So if we're talking about lions, then 30% of 30 is 30 over 100 times 30, which is 9 lions. So of those 30 big cats, we need to pick 9 lions. Whereas 70% are tigers, then we do 70 over 100 times 30, which is 21, which fulfills our 30 total. Yeah? So that's how you pick which from which category, if we're talking about stratified sampling. Sometimes they aren't represented as percentages, but you can find the percentages from the information. So we have a manufacturer that's producing chairs, tables, and beds. And we want to pick 37 pieces of furniture total. So if we have 240 chairs, 90 tables, and 40 beds, we first need to figure out how many total do we have. Well, that's 240 plus 90 plus 40, which is 370. So if we were to talk about the chairs, if we want to pick a total of 37 pieces of furniture, the chairs are 240 out of the total pieces of furniture. So we would do the percentage of it, which is your part over the whole, 240 over 370. It's like 30 over 100. It's just a different way of representing the percentage. And then you multiply that by 37. And what you get is 24. So you need to pick out 24 chairs. For tables, we have 90 tables, which means we need to pick out 9 for this sample. Beds, we have 40 beds, which means we need to pick 4 for the sample. So that's how you do stratified sampling, just a really quick overview of that. And let's move on to labeling types of sampling methods. So we've got a couple different sampling situations, and we're going to name the sampling method used. So Anke wants to find out the proportion of households in Germany who have a pet. For her investigation, she decides to ask her friends from a school, which is located at the center of a large city, whether their family owns a pet. So asking her friends means that she's asking a population that is convenient. So this is non-random, convenient sampling. Next, Leonie wants to collect information on the length of time pupils at her school spend on homework each evening. She thinks that this depends on the school year, so her sample should contain some pupils from each year of the group. Leonie decides to ask each pupil in the lunch queue until she has responses from at least 10 pupils in the year group. So this is not, the idea that we separate it into categories could either be quota or it could be stratified sampling. The only difference is how she decided to pick it, whether it's truly random. The thing here is that it is not truly random how she picked it. She didn't decide who she was going to pick before she encountered them. It's not truly random, so it is quota sampling. A student wants to conduct an investigation into attitudes to environmental issues among the residents of his village. He decides to talk to the first 20 people who arrive at his school or at his local bus stop. This is convenient. It's nearby. It's somebody who just shows up on something that he's doing on a day-to-day basis. Now, this could mean he's not talking to anybody. So he's already talking to people who are at a bus stop. So they're already aware of maybe climate issues with transportation. So he's not interviewing anybody who's renting a car. He's not interviewing anybody who's taking a helicopter. He's not interviewing anybody who's taking a plane to work every day, right? So there are people who do that, and he's only interviewing the people who are doing public transportation. So this is very convenient and potentially very biased. A shop owner wants to find out what proportion of the scarves she sells are bought by women. She thinks that this may depend on the color of scarves. She records the gender of customers who bought the first 10 of each colored scarf. Again, could either be quota or stratified, but it all depends on how she gathered the data. So she didn't gather a whole population and then pick from that population to then represent the data. So it's not random, and it is therefore quota. A park ranger wants to estimate the proportion of adult animals in a wildlife park that are suffering from a particular disease. She believes that the adults of these species present in the She believes that of the adults of these species present in the park, 20% are deer, 30% are tigers, 40% are wolves, and 10% are zebras. She decides to observe animals until she has recorded 10, 15, 20, and 5 zebras. Think about this as the fact that she has to fill a quota. She's not going and collecting data and finding different points of data to make it, right? So she's not going to extreme parts of the park to observe those different animals. She's only observing in a certain area and then saying, okay, once I've filled the quota that I have in the observations that I've done, and then she starts to dismiss observations that she's done, right? So she might observe a deer that has the disease, but she's already fulfilled her quota of the deer, and then she starts to dismiss data that she's gathering. That is not random, and therefore it is quota. So none of these are random. They are all non-random sampling techniques. Okay, we'll go ahead and practice this when I see you in class next.